So I'm going to take you through some more significant figure problems in order to kind of go through the rules again and see what we're looking for. Okay, so first off is how many significant figures are in the following numbers. And number one, the 0 at the end here is trailing and there is not a decimal place, so it is going to be 4 significant figures for number 1. Remember, as evidence that you've watched this video, you need to fill in the worksheet that you received. If you do not have the worksheet, you can write these answers down on a separate sheet of paper, but you need to at least show me that, that you've watched it. Okay, number 2, these zeros up front do not count, so I can cross those off. However, these numbers at the end are after a decimal place and at the end of a number. They will count. That is also going to be 4. Number 3, all of the zeros are going to count. This one is embedded. This one is at the end and it's after a decimal place, so it's going to be 5. Number 4, when we do scientific notation, we ignore that exponent, so this is going to be 2. And number 6, sorry, with number 4 and number 5. Number 5, there is a decimal place here at the end, so this is going to be 5 significant figures. Okay. Now the next section has to do with math, and remember with math there is 2 rules. If it is addition subtraction, it's the fewest decimal places, and if it is multiplication and division, it is going to be the fewest number of sig figs. So for example, number 6, if I do this out to the side, you've got 57 plus 2.98. Now you're still going to do the math, so you still get 59.98. And you can only write down a whole number, so that is going to round up. So it should be 60. In a perfect world, it's 60 with a decimal place, but honestly, for right now, if you put 60, I'd be good with that. Number 7 is also addition and subtraction, and when you do this math, excuse me, you should end up with negative 18.89. Okay, 2 decimal places is the fewest number you can write down here. Number 8, we switch gears, we get into multiplication division. Number 8, this only has 1 significant figure, so my final answer, even though my calculator is going to, if you do this on your calculator, you get 0.4869. That's going to round up to 0.5 as your final answer. And then for number 9, you can only write 4 significant figures, so my calculator is going to give me 0.781699. Can only write down 4 because this has the fewest number, so this is going to round up to 0.7817. And then last but not least, we've got some scientific notation problems. For this one, the 3.0 out here only has 2 sig figs, so your final answer when you do this out can only have 2 sig figs, so it should be 2.8 times 10 to the 21st. Okay, so there's a quick review of sig figs, both numbers of sig figs and problems, as well as math. Now on the back you have density problems, and as a reminder, you have to make sure that you do the known and unknown, you write the equation, you show the work, and all that good stuff. So I'm going to model that for us here. So for number 1, okay, we want to know the density. So the unknown is the density. It's what we're looking for. That has a mass of 4.32 grams, and each side is going to be 7.1 meters. So for example, on this one, in order to correctly solve for this, the first thing we have to do is find the volume. So for the volume on this one, it's going to be 7.1 times 7.1 times 7.1. So if I do 7.1 cubed, however you want to do it, 2 significant figures here, I can only write down, is that right? 7.1 times 7.1 times 7.1. There we go. My calculator gives me 357. I can only write down 2 sig figs, so I'm actually going to limit that to 360. And my unit is going to be meters cubed because it was meters times meters times meters. Now, I'm also going to then find the density, so I have to write my equation, which means write the letters only, and then I'm going to show the work plugged in. So density is going to be 4.32 grams divided by 360 meters cubed, and you're going to see why I plugged that in there in just a second. So 4.32 divided by 360 is going to give us 0.0 0.12, and it's going to be grams per meters cubed. Okay, so you get the units from the data that was given. 2 sig figs in my data, 2 sig figs in my answers. Okay, you probably won't have space to solve, well, you may have crammed this one in, that's fine. You also can flip over onto the back to solve the density problems if you want to do it that way as well. Okay, number 2. This time for number 2, my unknown is volume. I know the density, 1.58 grams per milliliter, and I also know the mass is equal to 12 grams. Okay, so I solve for density equals mass over volume, and I plug it in. 1.58 grams equals per milliliter is equal to 12 grams over the volume. Now, here's the thing. Big mistake people are going to make is how to solve for the V. And I showed you earlier how to manipulate the equation, how you can ultimately figure out that volume is equal mass over density. Or from this place, if you forgot to do that, if I multiply both sides by the volume, then I can get the volume on the top of a fraction, which is what I want. So now what I have to do is divide both sides by 1.58. I can only have 2 sig figs in my answer, so it should be 7.6, and my unit is going to be milliliter. Where did that come from? Well, remember, density is mass over volume. The volume unit for this particular density value was milliliter, so that is the unit that's going to go on my answer. Okay, last but not least, we're going to do a mass problem. So this time I want to know the mass. My density is equal to 3.59 grams per milliliter. My volume is 6.15 milliliters. Now, just as a quick check for mass here, my density is grams over milliliter, so my mass unit is going to have to be in grams. I plug in density equals mass over volume. I showed you sometimes how to also manipulate it into mass is always going to be density times volume. Either one is fine by me. I've got 3.59 equals mass over 6.15. And regardless, you're going to take 3.59, multiply it by 6.15. I can have 3 sig figs in my final answer. So my final answer here should be 22.1 grams. Okay, I hope that helped clear up some difficulties with sig figs and density. Bring this the next time as evidence that you've done your remediation, and let me know